In industries where safety is paramount, such as manufacturing, oil and gas, or medical devices, it's crucial to ensure that systems are not only reliable, but also safe for both operators and the environment. One key concept in assessing and managing the safety of such systems is the Safety Integrity Level, SIL. SIL is a measure used to define the relative risk reduction provided by a safety function within a system. A safety integrity level, SIL, is a discrete level ranging from 1 to 4, assigned to a safety function to quantify the level of risk reduction it provides. It is determined based on the probability that a safety system will satisfactorily perform its required function under all stated conditions for a specified period of time. The SIL rating system was introduced as part of safety standards, such as IEC 61508, Functional Safety of Electrical, Electronic, Programmable, Electronic, Safety-Related Systems, and IEC 61511, Process Safety in the Chemical and Process Industries. These standards guide organizations on how to manage and mitigate risks associated with safety-related systems. The higher the SIL level, the lower the likelihood of failure, and consequently, the higher the level of risk reduction required. SIL is usually applied in the context of safety instrumented systems, SIS, which are systems designed to monitor and respond to hazardous conditions by automatically taking protective action. SIL1, the lowest level, providing the least risk reduction, suitable for applications where the risk of injury or damage is low. SIL2 represents moderate risk reduction for systems with medium risk factors. High SIL3 is suitable for systems where failure could lead to serious injury or environmental damage. SIL4, the highest risk reduction level, is applied to systems where failure could lead to catastrophic outcomes, such as loss of life or large-scale environmental harm. In safety-critical industries, identifying and mitigating risks is not just a regulatory obligation, but also an ethical responsibility. SIL gives a concrete measure to the likelihood of failure and the associated risks of a system and helps engineers design systems that meet specific safety and performance standards. Many industries must adhere to international safety standards such as IEC 61508 or IEC 61511, which require SEL assessments as part of overall safety management. SEL ratings can also help improve system reliability, which is crucial in preventing accidents or reducing their severity when they do occur. Calculating the required CL for a specific safety function involves evaluating the risk associated with a failure. Begin by performing a hazard and risk analysis to identify the risks associated with system failure. Various methods can be used for this, such as failure modes and effects analysis, FMEA, hazard and operability study, HAZOP, or layer of protection analysis, LOPA. The key factors assessed include the likelihood of a hazardous event, the severity of the potential outcome, and the exposure time. Based on the risk assessment, the target SIL is determined by comparing the risk reduction required with the SIL levels. A risk graph assigns SIL levels based on risk severity and frequency of exposure. Layer of protection analysis is used to evaluate the existing safety layers and determine if an additional safety instrumented function is necessary to achieve the required risk reduction. Fault tree analysis helps to model potential failures and their effects on overall system risk. Once the target SIL is calculated, the next step is to verify that the system or the safety instrumented function can meet this requirement. This involves selecting components, testing, and ensuring redundancy, diagnostics, and system performance meet the defined SIL. Safety integrity levels, SILs, are essential in ensuring that systems in critical industries operate safely and reduce the risks of accidents or failures. Calculating the appropriate SIL involves a detailed risk assessment and understanding of the probability of system failure, leading to better informed decisions on system design and risk management. Whether you're designing a safety system for an oil refinery, an automated manufacturing plant, or a medical device, understanding and applying the principles of SIL will help you improve safety and meet the necessary regulatory standards. If you're ready to take the next step in enhancing your safety systems or need expert guidance on calculating and implementing SIL, contact us today at 1-888-600-3080. Our team of experienced engineers can help you design, evaluate, and optimize safety solutions that meet your specific industry needs and compliance requirements. Let's make your operations safer together.